Good afternoon, everyone. My name is Bridget LaFemina, and I'm with a company called Penn. Can I put these down? Yeah, there we go. All right. My name is Bridget LaFemina, and I'm with a company called Penn Globe, and this is Craig Becker with IMC Internet, and he is part of the. Oh, hello. And we are part of the Autonomous Notification and Data Collection System team. We are a local Connecticut team. Why is this? Sorry. Okay. So, being a Connecticut team, we started the idea for this project based on the shooting at Sandy Hook Elementary School. We found a need for pedestrian safety and security, and being from Connecticut, we wanted to come up with that solution, and we came up with the Autonomous Notification and Data Collection System, and Craig Becker is going to do a little bit of explanation for us.
Thank you. Thank you, Bridget. So again, my name is Craig Becker, and I am the owner of IMC. We're a business technology consulting company. And I think Bridget's being a little modest about Penn Globe in that they're an over 100-year-old custom lighting manufacturer, a very impressive client list, including Disney World in the private sector, Savannah, Georgia, Boston, Massachusetts, Harvard University, Lehigh, and my personal favorite, the University of Connecticut. Go Huskies. So Bridget's company brought us in order to take their existing, and I might say aesthetically beautiful, custom manufactured lighting and incorporate some smart technology into what is basically an open space within the pole. Thanks. So the first step was adding an IP network camera, security camera, to the light fixtures, which the Penn Globe team successfully lighted to provide an optimal image. But there had to be a way of collecting that data, and that's where my company came in to provide a way of passing the video over a variety of internet sources. So the first step in that project was to design a encrypted, secure network over a 4G LTE signal in the effort to make the lighting fixture sort of completely autonomous. So no wire would be necessary. And we successfully set that network up. Obviously, 4G bandwidth comes at a premium, and so in practical application, it may only be useful for sensor data rather than video data, but we do have a working model of that. The next step was to consider some other internet sources, so we've since come up with a point-to-point Wi-Fi connection, which we've implemented and tested. And we also, of course, could tie into a direct line fiber or Ethernet cable. And that application is currently in production. So the next stage in this development project is to look at a number of other sensors you've probably heard about a lot about today: traffic counting, gunshot sensors, meteorological data collection. There's a number of, once you've established the power and the data connectivity, there are a number of avenues for other data collection. For the purposes of this event, we focused on a glass break sensor. So we took a glass break sensor and integrated it with the IP camera system, and we were able to send a signal to the IP camera that would pan the camera to the point of origin of the sound source. The sensor itself only reacts to the specific sound of tempered glass or commercial plate glass breaking. It won't react to a bottle, squealing brakes, anything of that sort. And we were able to actually show that in a video, which is impossible to see because it's very bright in here. So those of you who are able to see it's okay. You're able to see our presentation out on the floor. We do have a working model of the glass break sensor, and we're looking forward to other opportunities to incorporate data collection into this device. All right, so if I remember the next slide, oh, there we go. Are you ready? Yeah, so we've got in partnership with a number of governmental agencies and politicians for this project, and Bridget's going to tell you a little bit about those relationships. Thank you.
The state of Connecticut had a lot to do with getting our team members together to create this system. Some of them have included Governor Daniel Malloy on the state level and our state senator Ted Kennedy. And just last week we had in the U.S. Secretary of Labor, Thomas Perez, and Rosa DeLauro, our congresswoman, and we showed them this system in working mode. I don't know how to do the video, otherwise I would. So, we have 2 minutes left, it's fine. So for the test bed for this project, we are going to be deploying this at the Stanley T. Williams Center in North Branford, Connecticut. We chose that location because of the purposes that that building serves. It's town offices, it's a daycare, a senior center, and it's also adjacent to a school. And there's also existing light fixtures made by Penn Globe on the property. And today, Craig kind of already went over the list of what we've accomplished as a team so far. And that's our team member list, but we plan on incorporating more sensors. As Craig said, we would like to incorporate this system into other smart city projects wherever people see it could be a good fit. We want to make quicker response times, and we've already got it down to less than 3 seconds. So we see this as being a system that can be utilized in a lot of different avenues, and it could be both here locally, it can be all across the nation and all across the globe. So please feel free to contact us if you have any questions, but thank you for your time, and thank you for everyone here at US Ignite and GCTC and NIST for putting this together. It's been great. Thank you.